Today's notes are on factoring polynomials when the a value is not equal to 1. The front page takes you through a complete example. The left side lists out the generic steps, and the right side lists out the steps for the example 6x squared plus 21x plus 18. The first step is to factor out the greatest common factor if necessary. So you can see that they pulled out a greatest common factor of 3. That leaves you with an a value of 2, a b value of 7, and a c value of 6. After you've factored out the greatest common factor, you're going to take the a value and the c value and you're going to multiply them together. Now, instead of finding factors that multiply to c and add up to b, you're going to find factors that multiply to a times c. So I want to know what multiplies to 12 and adds up to my b value of 7. So here are our values that multiply to 12, and they checked each of them for adding up to 7. So the last set works with the 3 and the 4. After finding the factor pairs, rewrite the polynomial into 4 terms by keeping the first and the last term the same, and you're going to write the middle term as the sum of the factors that we found. So we can see that the first term and the last term are the same. So is our greatest common factor that comes down with us. And instead of 7x, I'm rewriting it as the 4 and the 3 that I found. The order does not matter which you list first. You could do 3x plus 4x if you wanted. Alright, after you've rewritten this as 4 terms, we can now follow our steps for factoring by grouping. So you're going to group the first 2 and the last 2 terms together. So 2x squared plus 4x and 3x plus 6. Then continuing to factor by grouping, we're going to pull out the greatest common factor from inside the parentheses. So a 2x out of the first term, a 3 out of the second binomial. And we want to check that our 2 binomials are the same, which they are, which means that is your first factor pair. And the second one is your leftovers. So the 2x plus 3 becomes its own binomial. This answer here at step number 7 would be your final answer. However, you can go through and check to make sure that you did get the right answer by multiplying back out. So you would have to FOIL the binomials together, and then after you simplified that, you could distribute the 3, and you just want to check that it's the same polynomial that you originally started with all the way at the top. Let's look at the next page and do an example together. Alright, I want to start example 1 by checking to see if there's a greatest common factor. There's not, so I can go into identifying my a value, my b value, and my c value. Then I'm going to go through my steps, which means I'm going to multiply a and c together. Which gives me 30. So I want to list all of the factors of 30. So I have 1 and 30, 2 and 15, 3 and 10, and 5 and 6. After I have all of my factors listed, I need to figure out which one adds to b. So I want to know which adds to a positive 17. So I'm going to be using the factors 2 and 15. The next step told us to rewrite the expression using 4 terms. So my first original polynomial was 6x squared plus 17x plus 5. So I'm going to keep the first term the same, and I'm going to keep the last term the same. And I'm going to write the middle term as our two factors here. So the product of the two factors would be plus 2x and plus 15x. The variable on these factors should match with the variable on your b term. Next, I'm going to group the first two together and the last two together, and I'm putting an addition symbol in between them. And I'm going to pull out the greatest common factor. In the first binomial, I can pull out a 2x, leave me with 3x plus 1. And in the second binomial, I can pull out a positive 5, leaving me with 3x plus 1 again. So we know we did it correctly. So my final answer would be that repeated binomial, and then all of my leftover terms, so the 2x plus 5. And if I wanted to check, I could FOIL them together to get back to my original answer. Please try and do example 2 on your own.